वेलकम बैक माय डियर स्टूडेंट्स। शुरू अल्लाह के नाम से जो दिलों के हाल बेहतर जानता है। एक मर्तबा ज़रतश्त ने कहा था कि अगर किसी की भलाई करना फ़र्ज़ ना भी हो तो ये एक पुरमसरत चीज़ है, क्योंकि ये हमारी अपनी ही सेहत और ख़ुशी को बढ़ाती है। तो मैं उम्मीद रखता हूँ कि आप इस मुश्किल वक्त में दूसरों की भलाई का ख्याल करते रहेंगे। Today we are going to discuss the two main topics. One is the physics and society, and other is very important one, the measurement. First of all, we are talking about the physics and society. In this topic, you have to emphasize on the importance of physics in our daily life. As you know that the physics has played an important role in our daily life. When we wake up on the sound of azan called on the loudspeaker, that is a wonder of the physics. In homes, in schools, colleges, industries, we usually use the electric bulbs for the light. That is again a blessing of a physics. For transportation, nowadays we use heat engines in different forms: diesel engine, petrol engine, jet engine, rocket engine. All these engines are actually based on the basic principles of the thermodynamics, and thermodynamics is the very important field of the physics. In homes, we use usually refrigerators, air conditioners, and these are also working on the principles of the thermodynamics. In 19th century, human being became able to use the electricity, and the 20th century is known as the century of the physics because of the revolutionary concepts and inventions of the modern physics. So such type of importance you have to think about in this topic. The most important inventions, whenever you are asked that which are the famous and most important inventions of the physics, then you have to think or consider or select the motor and generator. Yes, the motor and generators have increased the pace of industrialization, and these machines are working on the principles of electromagnetism. You know very well. And in our present life, this present time is known as the world of telecommunication. This world of telecommunication, in which we use the radars and different machines, and all these radars means radio detection and ranging devices. These are all working on the simple principles of the reflection and detection of the light. But the most important and intelligent use of physics is observed in the field of medicine. In the field of medicine, nowadays we are using the ultrasound, a homosound machine, X-rays, and many other electrical tests for the diagnosis purpose. Such as we are using nowadays very important test, ECG, electrocardiogram, to check the function of the heart, EEG, electroencephalogram, to check the function of the brain, EMG, electromyogram, to check the function of the muscles, ERG, to check the functions of the human retina, means electroretinogram, etc. It means the intelligent use of physics has been observed only in the field of medicine. If you notice in your daily life, in homes we use mostly the electronic appliances such as television, DVD, microwave, oven, cellular phones, computers, laptops, etc. These all electronic appliances are working on the principles of the solid state physics. So it means if you notice in your daily life, the physics had played very important role in one way or in other way. Yes. Next topic is measurement. as you know that physics is qualitative as well as quantitative. Physics also deals with the correct and precise measurement of the material universe. It means on the basis of measurement we can find out the different facts and universal laws of the nature. For example, if I say, if we measure the mass of an object, with the measurement of the mass of object we can calculate its weight, we can calculate its density, we can calculate the force acting on it due to the force of gravity of the earth, and on the basis of measurement of the force of gravity of the earth, Newton became able to give his famous Newton's law of universal gravitation. So it's very important that with the measurement we can find out the different facts and the laws of the nature. But now the basic question is that what is measurement? Measurement is nothing but it is only the comparison of a physical quantity with a set of its standards. So how? For example, the standard of the length is 1 meter. If I bring 1 meter to calculate the length of this wall, then I will say this wall is 5 meter. It means the length of this wall is 5 times greater than the standard of the length. So this is measurement. So measurement is only the comparison of a physical quantity with its set of standards. When I say set of standards, means length can be measured in the meter, standard, in centimeter, standard, foot is a standard, kilometer is a standard, mile is a standard. So that's why I am talking the set of standards, because there is no any single standard, but there are different standards nowadays being used for the measurement of the physical quantities. Okay, come to the conclusion. So measurement is only the comparison of a physical quantity with a set of standards. Yes dear students, हमने पढ़ा कि measurement या नापतोल किसको कहते हैं. तो हमने सीखा कि नापतोल या measurement इसको कहते हैं कि किसी भी physical quantity को हम उसके standard के साथ compare करें, इसको नापतोल कहते हैं, इसको हम measurement कहते हैं. तो सवाल ये पैदा होता है कि what is a physical quantity? तो फिजिकल क्वांटिटी हम हर उस चीज़ को कह सकते हैं जिसको हम नंबर में एक्सप्रेस कर सकें. As I said, the length of this wall is suppose 3 meter. It means length is a physical quantity because length can be expressed in numbers and related to non-living thing, that is known as a physical quantity. So anything which is measurable and can be expressed in a number and related to non-living thing is known as a physical quantity. Similarly, if I say the mass of that person is 65 kg, so mass is a physical quantity. If I say the time is a physical quantity because time is nothing, it is only the interval between two events. So time is, suppose the time is 15 seconds. The time can be expressed in a number, so that is why time is a physical quantity. But can you measure the honesty of any person? This person is 5 honest, this person is 6 honest. No, I am 0 honest. No, you are 100 honest. No, because honesty, kindness, sadness, love, hate, all these abstract concepts are not physical quantities because we cannot express these in number. So anything which can be expressed in a number is known as a physical quantity. And all physical quantities are written in this form. Any physical quantity must have a numerical value, and has a particular unit. So we can say Q denotes the physical quantity, N is the numerical value of that quantity, and this U is means the size of the unit. It may be in second, it may be in minute, it may be in years, months, weeks, days. So all physical quantities in physics are written in this form. Yes. So हमने पढ़ा कि फिजिकल क्वांटिटी को हम इस तरह एक्सप्रेस कर सकते हैं कि एनी फिजिकल क्वांटिटी मस्ट हैव अ न्यूमेरिकल वैल्यू एज वेल एज इट्स पर्टिकुलर यूनिट. Now let's see another thing that will be very important for you to use in the coming problems in the physics. Which one? If I say that the mass of an object in SI system is 65 kg mass of person. Similarly, if I want to express the same mass in CGS system, means in grams, then I can say the same mass of the same person is now 65,000 gram. Yes, it's same thing. But what happened? As I changed the unit from SI to CGS, as I shifted from the larger one unit to the smaller one unit, then the numerical value has been increased. This is very important point. It means we can say if the the quantity is similar one but the unit has been changed, so we can write quantity is similar one, then the product of N1 U1 will be equal to N2 U2 because the quantity is same. तो हम इस तरह लिख सकते हैं कि उस क्वांटिटी की वैल्यू सेम है लेकिन यूनिट को हमने चेंज किया है तो उसकी न्यूमेरिकल वैल्यू भी चेंज हो चुकी है लेकिन क्वांटिटी सेम है तो इसको हम इक्वल लिख सकते हैं. So if I want to compare what is the relationship between the unit and the numerical value, let's see. N1 I can write this by cross multiplication, U2 over U1. So I think it's very clear that the numerical value of any physical quantity is inversely proportional to its unit. So it means as you decrease the value of the unit, the numerical value will increase. इसी चीज़ को हम एक और एग्जांपल से भी समझ सकते हैं. As you know that the value of G in SI system is 9.8 meter per second square. If you want to write this value in CGS system, then you have to convert meter into centimeter. It means you have, as you know that there are 100 centimeters in 1 meter, then you have to multiply 100 with this, so it will become 980 centimeter per second square. What happened? As I decrease the value of the size of the unit, then the numerical value of the same quantity has been increased. So it means it is very clear that the numerical value of any physical quantity is always inversely proportional to the unit of that quantity. That is why we always write quantity is the product of numerical value and its unit. Product means inverse to each other. Very clear. Okay, the next part. As you know that physical quantities, there are various physical quantities are being studied in the physics. But all physical quantities are further divided into two groups. One is the basic quantities, other are the derived quantities. First of all, basic quantities. Basic quantities, or we can say base quantities, or we can say fundamental quantities. किन को कहा जाता है? हर उस क्वांटिटी को, हर उस मिकदार को आप बुनियादी मिकदार कह सकते हैं, जिसको आप डायरेक्टली मेजर कर सकते हैं, जिसको मेजर करने के लिए आपको किसी और फिजिकल क्वांटिटी को मेजर करने की ज़रूरत ना पड़े. आप एक टेलर मास्टर के पास जाते हैं, वो आपके कपड़ों की नाप लेता है, तो वो आपकी डायरेक्ट अब आपकी लेंथ को मेजर करता है, आपकी विड्थ को मेजर करता है। यस, लेंथ और विड्थ बोथ आर सेम थिंग्स, मीन्स बोथ आर लेंथ्स। सो उसको लेंथ मेजर करने के लिए वो ये आपसे नहीं पूछता कि व्हाट इज द मास ऑफ यू, व्हाट इज योर मास। वो आपसे ये नहीं पूछता कि व्हाट इज योर एज। नो, it means length is a physical quantity, but which one? Length is a basic quantity. To express the length, we don't have the need of the mass, time or etc. No, it means length is a basic quantity, mass is a basic quantity, as well as time is a basic quantity. Now you can express what are the basic quantities. Those physical quantities which can be expressed independently, or you can say those physical quantities which do not depend on other physical quantities, or you can say though the quantities which can be measured directly with the help of measuring instrument are known as the basic quantities. How many basic quantities have been selected in physics or science? There are 7 basic physical quantities as you see in the chart of your textbook. These are all 7 basic quantities. Very important, you have to remember first to proceed further. So length, mass, time, temperature, amount of substance, luminous intensity and current, these are all 7 basic SI quantities. And they have the particular units. As you know, length is measured in meter, mass in kilogram, time in second, temperature in Kelvin, amount of substance in mole, luminous intensity in candela, current in ampere. So these are the 7 basic quantities. But we also have to calculate the other quantities in the daily life. These all quantities will be the derived quantities. So only 7 basic quantities are there, 2 supplementary quantities are there. One is the plane angle, other is the solid angle. Derived quantities को हम directly measure नहीं कर सकते. इन quantities को हासिल करने के लिए पहले आपको basic quantities को नापना होता है. जब बेसिक क्वांटिटीज़ को हासिल कर लेते हैं तो उनको आपस में या तो मल्टीप्लाई किया जाता है या तो डिवाइड किया जाता है. आफ्टर मल्टीप्लिकेशन और डिवीजन आपको जो भी नई क्वांटिटीज़, नया मिकदार हासिल होता है उसको हम कहते हैं डिराइव्ड क्वांटिटी. सो डिराइव्ड क्वांटिटीज़ ऑलवेज डिपेंड ऑन द बेसिक क्वांटिटीज़. Derived quantities are explained in terms of basic quantities. Derived quantities are obtained by multiplying or dividing or both the basic quantities. For example, let's see derived quantity. Okay, select any basic quantity, derived quantity. Suppose area. Area is a derived quantity because for the calculation of area we have to calculate first the length of this hall as well as the width of this hall. After measuring these two basic quantities, we will be able to calculate the area of this hall. It means area is a derived quantity. For the area, we have to calculate two lengths. One length, other width. They are required to calculate the area. It means area is a derived quantity. Similarly, as you calculate the speed of any object, the speed of any object means how much it is going slow or fast, that is speed. We will study further. Speed is defined as the rate of change of distance, or simply we can say speed is only the ratio of distance to the length. Distance means length, t is the time. So it is only the ratio of the two basic quantities. It means speed is obtained by dividing a length with the interval of time. So we can say speed is a derived quantity. Similarly, you know that momentum is there. Momentum is the product of mass and velocity. Mass is a basic quantity. Velocity is again a derived quantity, but velocity is defined as the displacement per unit time. So can we say for the measurement of the momentum, we have to multiply mass and length, basic quantities, and we have to divide time. Time is again basic quantity, but momentum is a derived quantity. So I think it is very clear that the all derived quantities are obtained by multiplying or dividing, or both the basic quantities are known as derived quantities. So now you name it and have it. All other quantities other than the basic quantities are all derived quantities. For example, force is there, pressure is there, tension is there, power is there, angular momentum is there, anything, any other quantity. Now, as you know that every physical quantity has a particular standard with which it is compared, and the standard of each physical quantity, either basic or derived, that standard is also known as the unit of that physical quantity. For example, the standard of the mass is kilogram. It means kilogram is the unit of mass. Standard for the force is taken as Newton, so Newton is the unit of force. Standard for the pressure is Pascal, so we can say Pascal is the derived unit for the pressure. So it means physical quantities are there as well as units are there, but there is no any single unit, single standard for all physical quantities in the whole world. That is why there are different systems of units. What is system of unit? You can say a set of standards of units, a set of standards or a set of units is known as the system of units. But there is not a single set of standards. So therefore there are different systems of measurement or units in the world. For example, first one we want to discuss, that is FPS system or British engineering system. So it is obvious from the name, this system was devised by the British people. In FPS system, you have to be clear. F stands for foot, and foot is the unit of length. P here stands for pound, and pound here is not stands for the mass, but pound stands for the force. Because in FPS system, force is considered as the basic quantity and mass is considered as a derived quantity. Yes, this is ambiguity is there. In other systems, mass is considered as the basic quantity and the force is considered as a derived quantity. But in this system, here whenever you are asked about P you have to say pound, and pound is the unit of force, not mass. Then you will ask which one is the unit of the mass for in B system or FPS system. So for mass, and they consider the mass as a derived quantity, and for mass they use a standard that is known as the slug. One slug is equal to 14.6 kg. So that is why if ever you are asked about the slug, so you have to say slug is the unit of mass in FPS system, and mass is considered as a derived quantity. Then you will ask about, sir, what is the value of the 1 pound force? 1 pound force is equal to 4.45 Newton, because you have to compare pound with the Newton. In SI system, Newton is the unit of force, but in FPS system, pound is the unit of force. Then you have to calculate how many Newtons are there in 1 pound. For this calculation, if you consider the Newton's second law of motion, you know very well. If we want to calculate the force in FPS system in pound, and that is written as pound force. Why pound force? I will explain. 1 pound force is equal to, as you know, that mass in FPS system is measured in the cylinder, and in FPS system acceleration must be written in this unit, foot per second square. Now if you replace the one slug in kilogram, we can write 14.6 kg, and 1 foot you have to convert into a meter. Then always remember 1 meter is equal to 3.3 feet, or we can say 1 foot is equal to 0.304 meter. 1 yard is equal to exactly 3 feet, but 1 meter is not exactly equal to 3 feet, but 1 meter is equal to 3.3 feet, and 1 foot is equal to 0.304 meter. So we can write here 0.304 meter, and per second square is same, because the unit of time in all systems of units is similar one, that is second. After multiplying these values, you will get approximately value equal to 4.45 kg meter per second square, and you know that kg meter per second square is also known as Newton. It means 1 pound force is equal to 4.45 Newton. It means we can say approximately 4.5 Newtons force is equal to 1 pound force. So very important this value. Again there is confusion in this system. Yes, British people use pound for the force, as well as they use pound for mass. In officially you have to say pound for force, but commercial unit, in commercial trade, they also use the word pound, but that is not pound force, but this is known as the pound mass. Then 1 pound mass is equal to what? Then you have to remember 1 pound mass is equal to 0.45 kg. It means approximately half kg cake is equal to 1 pound cake. If you want to get this 2 pound cakes, it means that will be equal to 1 kg. Or you can remember 1 kg will be equal to, if you divide this 0.45 with the 1, you will get 2.2 pound mass. It means 2.2 pound mass value is equal to 1 kg. When you get the cake of 2 pounds, it means that is equal to 1 kg. So there was confusion. I stated little bit 1 pound force whenever you asked, that is the unit of force, and that unit is considered as the basic quantity, basic unit in FPS system or B system. 1 pound mass is asked, then you have to say that this unit is actually slug and pound mass in FPS system as a derived unit. This is a little bit confusion is there, so I state little bit. Now come to another system, that is CGS system. CGS system was given by the French people. As you know, the French people and British people have fought for 100 years. Their 100 years wars are very famous. So the French were against the British people. So that is why they didn't accept their system, but they devised their own system, and that is known as the CGS system. CGS system is very simple one. C stands for centimeter for length, G stands for gram, is the unit of mass, S stands for second, again unit of time. But in 1790, again French people gave very important, famous and acceptable system of units, that is MKS. Yes, MKS system is also known as the metric system. This system was devised by the French people. Yes, French people were very intelligent people as compared to the British people. They devised MK system. Here M stands for meter for length, K stands for kilogram, unit of mass, S stands for second, unit of time. But the importance of MK system is this. In this system, the French people first time introduced the meter as a unit of length. And the unit of length is very important, 1 meter, that is being used till now. And this system is also based on the factor 10. Okay, now I tell you that 1 meter was compared with watt by the French people. As you know that this one is the sphere of earth. If we imaginarily divide into two hemispheres, one is the north hemisphere, other is the south hemisphere, and this imaginary line between the both hemispheres is known as the equator. The French people actually calculated the distance from the north to the equator of the earth, but that distance must be passing through the Paris. Paris is the capital city of the France. Then they said actually divided this distance into 1 crore parts, and the one part of this system was named as the 1 meter. Very interesting. 1 meter is now said to be the distance equal to 1 croreth part of the distance between the equator and North Pole, but passing through the Paris is known as the 1 meter. So 1 meter is the 1 croreth part of the distance between the equator and North Pole passing through the Paris. And they divided 1 meter into 10 parts, and each part is known as the decimeter. Again, decimeter was divided into 10 parts. Each part is known as the 1 centimeter, and again divided 1 centimeter into 10 parts, and each part is known as the 1 millimeter. And now we can say 10 millimeters are equal to 1 centimeter, and 10 centimeters are equal to 1 decimeter, and 10 decimeters are equal to 1 meter, and 1000 meters are equal to 1 kilometer, 100 meters are equal to 1 hectometer. So this system was very simple one. So we can say this system is based on the factor 10. So these were the two important points of the MK system. But don't confuse 1 meter with the 1 yard. Yes, 1 yard is the distance equal to 3 exactly feet. 1 yard is equal to 3 feet exactly. But 1 meter is not exactly 3 feet, but 1 meter is equal to 3.3 feet. So we can say meter is different from the yard. 1 meter is little bit larger one than the 1 yard. So that was the history of 1 meter that was introduced by the French people in 1790. Very interesting and important system is this that is being used till now. Then you will ask, sir, how this system is being used till now? Nowadays we are using the SI system. Yes, SI system was decided by the scientists of the whole world. They sit in 1960 at Paris and decided to use the one acceptable system among these systems for the whole world, and that system was selected actually MK system. MK system nowadays said to be SI system. So now we can say that in SI system MKS system is included, because MKS system was very logical one, was rational, was coherent. So due to these properties, MKS system was introduced as a SI system. When we say SI system, actually this name is in French, so not international system as in English, but you have to say SI, means Système International D units. Sometimes we write le is actually in the place of the, and D is in the place of. So in English, if it was written as the International System of Units, but in French people it was named as le Système International D units. So actually when it is asked that SI is the abbreviation of what, then you have to tick this one, Système International D units. But you have to remember, SI system consists of MKS system. In MKS system, other unit is also